Hey guys, welcome back to another video. Today we will be doing the IGCSE Add Math Trigo topic, and because the 2025 papers don't include calculators, so basically you can't use calculator in the paper, so I'll be teaching you guys how to tackle those kind of questions even without a calculator. Okay, so this is the first question from February March of 2025, and it's from paper 1, which is the non-calculated paper. Okay, so the question is asking, the diagram shows the curve y equals a cos bx plus c for minus 180 to 180. It's given that a, b, and c are integers, and you need to find the values of a, b, and c. Okay, so when you first look at this question, you need to note that the domain is this, and then you know that this is the cos graph, and they also showed you on the diagram. And the second thing that you need to note is that A is the amplitude, B is and C shows you how much the graph is translated by 2 pi over the period. So you need to know these three things. Okay, so first we can figure out the amplitude of this graph. So to do that, you look at 3 and minus 7. The difference between 3 and minus 7 is 10. So here is, here is 10 units. And if you look at a cos graph, it's supposed to look something like this. So you would know that the amplitude is 5 and minus 5. So, because the difference is 10, right? So 5 minus 5. So now you need to write an amplitude, or A is equal to 5. And the second thing for is B. So here is how many full cos graphs is within B is 2 pi 360 over degree. period. So if you look at this diagram, you can see a complete cos graph here. So you have 1.5 cos graph within 180. So we can use simple ratios to figure out the value of B. So 1.5 or 3 over 2 is to 180 degree. And since period is how many full cos graph is within 360, we want 360. So 180 times 2 is 360. So 3 over 2 times 2 is 3. So B is equal to 3. Okay, and lastly, we need to find the value of C. And C is how much the graph is translated upwards or downwards. So we know that a normal cos graph looks like this, and with amplitude 5, it will look like this. But then now, we have the value 5 here, but here is 3. So 5 minus 3 is 2. So we know that the graph moved down by 2 units. So C will be minus 2 since it's moving down. And the notation, the negative sign, shows that it's moving down. If it's positive, it's moving up. Okay, so now you can rewrite this as 5 cos 3x minus 2. But actually they want you to find the values of A, B, and C, so you don't really need to write this, but you can also write it. Okay, so the next question is also from the same paper, and this one is a bit different though. It's not the graph. So they give you tan theta equals root 5 over 5, and then the domain 180 to 360, and you need to find the value of cos theta. So the way you can do this is you can actually use the trig identity, 1 plus tan squared theta equals secant squared theta. And then since you are given tan theta, the square of that would be 5 over 25 equals 1 over cos squared theta, because we want to find cos theta, right? And since we have secant squared theta, which is equal to 1 over cos squared theta, I'll just replace that with that. And then now I'm going to simplify this part first. So 1 plus 1 over 5 is also equal to 6 over 5. And then the reciprocal of 1 over cos squared. The reciprocal, basically 5 over 6 is equal to cos squared theta. And cos theta is equal to 5 over 6. And okay, so if you look at this, add sugar to coffee, sine is positive in the second quadrant, tan is positive in the third quadrant, and cos is positive in the fourth quadrant. So when tan theta is positive, it means that it's in the third quadrant, and cos cannot be positive. The only time that tan and cos can be both positive is in the first quadrant, but since the question says that it's between 180 to 360, it can only be the third or fourth quadrant. And since we know tan is positive, cos must be negative. So it's actually negative root 5 over 6. And the second part of this question, part B, you need to find the value of sine theta. To do this, we can use tan theta equals sine theta over cos theta. And sine theta is just tan theta times cos theta. So we have cos theta from this part. We can get root 5 over 5 times minus root 5. Wait, actually I'm going to split this. So root 5 times root 5 is 5, then 5 root 6. You can simplify, and if you want to rationalize this, okay, so we need to check the sign, make sure it's correct. So once again, tan is positive, and it can only be negative here because it's also within the n4th quadrant. So yeah, it's negative. And now part C, we need to find the value of secant theta plus cot theta, giving your answer in this form. Okay, so what we know about secant and cotangent is that secant is 1 over cos theta and cotangent is 1 over tan theta. And we have cos theta and we have tan theta from the previous part of the question, so we can just sub it in. So 1 over cos theta is minus root 6 over root 5. And 1 over tan theta is 5 over root 5. Okay, notice how they have the same denominator, so we can just add it up. And yeah, this is the form that the question wants. So A is equal to 5, B is equal to minus 1, C is equal to 6. So this is the final answer. This is the next question from the 2025 specimen paper. And for this question, you need to note that all the angles are in radians. And part A, you need to write down the amplitude of 2 cos x over 3 minus 1. So this is easy, it's just a number in front of cos, which is 2. And period of this graph, okay, so period is the length of one full cos graph. So what we know is that the coefficient of x is 1/3. So within 2 pi, you have 1/3 of the cos graph. So to get one full graph, you need to multiply by 3, and then you will get 6 pi as the period. 6 pi radians. Okay, part C, you need to sketch the graph for this within minus pi to 3 pi. Okay, so the way to do this is, you already know that the amplitude is 2 and that the period is 6 pi. So basically, for 6 pi, that means it's one complete cos graph, which will look something like this. So this is 6 pi. So the domain is only 3 pi. So we only want until here. So we know that it will look like a half of the actual cos graph. And then we know that the amplitude is 2, so it will be something like this. But since there's a minus 1 at the back, the graph will move down by 1 unit. So if you move down by 1 unit, it will be 1 minus 3, and it will look something like this. Here is 3 pi. But okay, so we don't know exactly where the graph will cross the x-axis. So the easy way to figure out where the graph crosses the x and y axis, actually just the x-axis, is to stop the x values inside the equation. Cos pi over 3 is also equal to cos 60 degree if you work in degrees. So it's just a half minus 1. And that's just 1 minus 1, which is 0. So when x is equal to pi, y is equal to 0. So we know that the graph will cross at pi 0 and minus pi 0. And we can actually double check for 3 pi as well. So y equal to cos 3 pi over 3 will give you pi minus 1. Okay, so 2 cos pi is minus 1. 2 minus 1 minus 1, which will give you minus 3. So when x is equal to 3 pi, y is equal to minus 3. So this part is also correct. Okay, so there isn't actually a lot of trig questions that you can practice for non-calculator papers. So what you can do is that you can go use the previous past papers, which you can actually use calculator in, but you can practice your answering technique, so like how to tackle these kind of questions, but you may not know the standard answers for those kind of questions, but it's okay because you will know how to approach the questions. Okay, so for this question, we need to solve the equation for minus 90 to 90. And what I did is that I wanted to change the cotangent into cosecant because there's this trig identity, 1 plus cot theta. Actually, there's no square. Let me write it. 1 plus cot theta equals cosec theta. And since there's a square in this question, I just squared everything, and yeah. So I rewrote it as cot squared 2 theta equals to this. Remember that there's a 2 theta. And then after I got this, I stubbed it into this part so basically I wrote this cosec square 2 theta plus 3 cosec 2 theta, and then I bring 9 to the left side. Minus 1 minus 9 is minus 10, and then it's equal to 0. Okay, now I factorized it into it's like how you would normally solve a quadratic equation. And then this is equal to 0, this is equal to 0. So what you would normally do is cosec 2 theta plus 5 is equal to 0. And then minus 5 cosec 2 theta is equal to minus 5. Cosec 2 theta is equal to 1 over sine 2 theta equals to minus 5. So sine 2 theta is equal to negative 1 over 5, which is what I did here. And you do the same thing for this side. So cosec 2 theta minus 2 is equal to 0. And then cosec 2 theta is equal to 2. 1 over sine 2 theta is equal to 2. Sine 2 theta is equal to a half. Okay, now you can solve these two, but for minus 1 over 5, you can't solve it because you don't actually know the exact value. So normally you would use a calculator for this, so obviously it won't come out for those non-calculator paper, but you know the standard answer for a half. So it'll be 30, and then since it's 2 theta, you will divide 30 by 2 to get 15. And since sine is positive in the first and second quadrant, you can visualize it like this. In the first quadrant is 30 degrees, and this is the second quadrant. So the second angle will be 180 minus 30, which will give you 150, as you can see here. So to get 2 theta is 150 divided by 2 to give you 75. So you should have more answers from here and then 2 answers from here. So this is another example of the questions that you can practice on even though it's from a calculator paper. So basically you're given this and you show that this. The first part of this question is more about differentiation, and you have y. So if you want to skip, just go to the So you can differentiate this equation, and the way I differentiate it is that you need to make sure it's 3 sine x times 2, and then differentiate sine as well. So it's like this to get 6 sine x cos x. And then if you differentiate cos x, it's minus sine x. So in the final will be this. And then if you look at this equation, y is this equation. Cot x you just write normally, and dy dx is from here. And then you will get this. Now what you can do is that you expand this. So cot x is 1 over 10 x, which is also 1 over sine x over cos x, which will then give you cos x over sine x. So that's why I have that here. And then when you multiply this by this and minus sine x, you'll get this entire part basically. And then since you have sine x and sine x, you can cancel, which will give you cos squared x multiplied by 6. And then this multiplied by sine x you will cancel and get cos x. And then cos x minus cos x will cancel out, which will leave you with 3 sine squared x plus 6 cos squared x. So they want it in the form k multiplied 1 plus cos squared x. So if you look here, there's 3 as the factor, and you can change sine squared x into 1 minus cos squared x. This is using the trig identity. So that's what I did here. And then when you can take minus 1 cos squared x plus 2 cos squared x to get cos squared x. And this will be the final answer. And then the second part, using your value of k, which is 3, solve this equation. And it's between minus pi to pi. So what you can do is rewrite it and then bring 3 to this side to get 1 plus cos squared x equals to 4 over 3. And then there's a square. No, you need to bring 1 to the other side as well, which will give you cos square x equal to 1/3, and since there's a square here, it's just cos x equals to 1 over 3 plus minus, because it's square root. And obviously you won't know the standard answer for this, so you can just leave it here. And that's it for this video. Thank you for watching, and I hope this has helped many of you guys.